Could we extrapolate this same logic to our entire universe? What if the cosmos is nothing more than Conway's game of life, but on an unimaginable scale? In this game, the board is the cosmos. The pieces are not cells, but the most fundamental particles, quarks, electrons, photons, and the rules are the two great pillars of modern physics: general relativity, which governs the immense, gravity, and the very fabric of space-time, and the Standard Model, which rules the universe of the tiny, particles and their forces. Of course, we know these rules still need to be unified, and that there are still rules for us to discover, rules that might explain dark matter, dark energy, or how gravity merges with the other forces. But let's focus on what these rules, as we currently understand them, can do, because that's where the real magic begins. On its own, one of these particles is not complex at all. Now let's sit back and watch how the system evolves on its own over almost 14 billion years, applying these rules over and over and over again. What happens? Right after the Big Bang, the universe is a soup of energy and fundamental particles too hot to form anything stable. But as it cools, energy condenses, and matter, as we know it, emerges. For a brief window, between 3 and 20 minutes after the Big Bang, the universe had just the right temperature and density for particles to fuse, giving rise to the two simplest atoms, hydrogen and helium. The universe had created its first building blocks. Gravity enters the stage. Acting on vast clouds of hydrogen and helium, it compresses them until the pressure is so brutal that stars ignite. These are factories of emergence, cosmic furnaces that, through nuclear fusion, cook simple atoms into far more complex ones: carbon, oxygen, iron. And the existence of these new atoms, with their dancing electrons and astonishing ability to form bonds, is not a new rule. It is a natural consequence, an emergent property of the fundamental laws of physics. Thus, across eons, from simple physics, chemistry emerges. The game continues, but now the board is the primordial soup of early Earth, a vast chemical laboratory brimming with the very ingredients forged in the stars. Over millions of years, those atoms interact, bond, and recombine, forming increasingly complex molecules. Amino acids emerge, the building blocks for constructing the first molecular machines. Nucleobases emerge, the letters of a future genetic language. And lipids emerge, and they do something that borders on magic. When mixed with water, they spontaneously form a barrier, a membrane that, at last, separates an inner world, protected, from the outside, the protocell, the first sketch of an individual. From chemistry, biology emerges. But a simple bubble, a protocell, isn't enough. To cross the next threshold, this system must do three things: capture energy from its surroundings, maintain its own structure, and most crucially of all, make copies of itself. When a network of molecules achieves this incredible balance, inert matter crosses a sacred boundary. Life emerges. And this life is not a spirit or a supernatural breath. It is a process, an astonishingly complex pattern that emerges from inert matter. The virus is the perfect illustration of this frontier. It's just a package of chemistry, inert, until it finds the right environment. And then, its most astonishing emergent property, self-replication, is unleashed. But complexity doesn't stop there. With life, a new game begins, the game of survival. Evolution, guided by natural selection, favors those who best process information. And thus, nervous systems arise, first simple, then more complex, until they become galaxies of thought. Networks of billions of neurons, like the ones inside our own brains. From biology, intelligence emerges. Let's pause here. We've climbed an extraordinary ladder, and it's natural to feel the vertigo. Let's look back. From physics, chemistry emerged. From chemistry, biology emerged. And from biology, intelligence emerged. Each step, a layer of complexity that wasn't programmed, but seems to arise naturally from the preceding rules. And it is here, at the top, that we face the final question. What about consciousness? Could it simply be the final step on this astonishing ladder? Or are we stepping into a mystery that science has yet to fully unravel? To even begin to answer, let's take it step by step. Because for this ladder to make sense, for order to arise from chance, we must understand the secret ingredient, the most powerful concept of all, time.